Hi, Mr. T here. This is the first video I'm going to do looking at Level 1 NCA Physics. We're going to specifically look today at what are physical quantities. Now, there are lots of things that we can observe around us. We can observe that when I look outside that it's blue, the sky is blue, I can see that the trees are green, or I can look and stand on the scales and I can observe that my mass is 80 kilograms. Now, if I can make an observation or a measurement that gives me a size, a numerical number, a number and a unit, what I'm getting there is a measurement of a physical quantity. So we can make lots of different physical quantities. So as I did, I can measure the physical quantity 80 kilograms, and we might know that this is the quantity of mass. I could go out and measure the distance it takes from two power poles, from one power pole, and then walk to the second power pole after that. And I might find that that is 100 meters. That is a measurement of distance. The physical quantity for the 100 meters is distance. I know it's a physical quantity because I have a number that I've measured and a unit at the side of it. The next number that I have is also a physical quantity. It could be the time it takes me to walk that 100 meters, and that is 24 seconds. It has a size, a number that denotes what the size or the measurement is, and a unit. And this is actually the quantity of time. So now we've introduced three different physical quantities: mass, distance, time. Every physical quantity, whether it's mass, distance or time, also has a symbol that is an abbreviation for it that we use in replace of saying distance. We have a symbol that we can use instead of it. So we can see down here that distance, its symbol is D. And then we've got symbol for time, mass, temperature, speed, acceleration, force and energy. They all have their abbreviated symbol. Now their symbol can either be a lowercase or sometimes it's an uppercase. But that symbol relates specifically to the quantity it is next to. Notice also that sometimes the same letter could be used for two different types of quantities. There are so many different physical quantities that sometimes you might use the same symbol. You will know which symbol it means which quantity because of the equation it's been used in. And in this case, we can see for time and temperature, one is a lowercase and one is an uppercase as well. Okay, the thing I want to talk about is what is the standard unit? Now at the bottom here, I've put down a physical quantity, distance. Its abbreviated symbol is next to it, D. We can measure different distance in lots of different ways. We can measure it using the imperial system. Now this is the system that countries that were in the old British Empire used to use up until about the 1970s. And that system measures things in inches, feet, yards, miles. There's such a thing as a chain. An inch was defined as the distance of the second bone from the end of your, so if you take your finger, your forefinger, and you take the second bone from the end, that whole length of that bone between the two joins, between the first and the second join, that is defined as an inch. A feet was defined as the length of a person's foot. A mile was defined as so many feet. I don't remember how many that is off the top of my head. A chain, interestingly enough, is 66 feet or 22 yards. And interesting, the length of a cricket pitch from the stumps to the stumps is defined as 22 yards or one chain. The length of the 22 on a rugby field from the try line to the 22 is also one chain. So these old imperial units were used for measurements on sports fields as well. But since we've adopted the metric system in the either the end of the 1960s or the start of the 1970s, let me know exactly when that was. We use the distances meter, kilometre, we can actually use a light year. Now light year isn't a measurement of time, it's a unit that is how far light has travelled in 1 year. And that happens to be something like 9.5 million kilometres. So that amount of kilometres is equal to a light year. However, only one of these, of all of these 4 different ways that we could measure distance, sorry, 7 different ways we can measure distance, only one is the standard unit, or the unit that we're all going to use in physics in our equations, so we get answers that are the same as everybody else. Everybody uses this unit, apart from if you're in the United States. In the United States, they won't use this unit, they'll use feet. What we use in the rest of the world is the meter. The meter is the standard unit for measuring distance. It's called an SI unit because we use the French phrase Système International, SI, because the French came up with a metric system, so they got to use their language to denote that this is an SI unit. So here we go, this is a meter, the SI unit for distance. Okay, here's a physical quantity for mass. Again, we have lots of different ways of measuring mass. You can stand on the scales, and if you look at your bathroom scales, it'll have an opportunity to measure in pounds. In the United States, their standard unit is in pounds. There is another unit called stone, which is equal to 14 pounds. There's a unit called grain. Now, grain is the weight of a grain of wheat. So if you took an average grain of wheat, that is equal to 1 grain. So you can imagine that it might take something like about 150 grains of wheat to equal 1 gram. So it's a smaller unit than a gram. A carat is a specific unit that's used to measure the mass of a diamond. So you can have a 1 carat diamond, you can have an 8 carat diamond, or you might have a 1/4 carat diamond. And so carat, a specific measurement of mass, but it's used just to measure diamonds. And then we've got a gram, a kilogram, and a ton. Now those 3 units are all metric units. They're all units that use the decimal system. They go up in tens, hundreds, and thousands. When we do physics calculations, however, we only use kilograms in our calculations. Kilogram is our SI unit, our standard international unit. So here are a bunch of other physical quantities that we are going to encounter when we do physics on this topic. They range from distance to energy. Every quantity has its own symbol, and every symbol associated with it has the standard unit that we will measure it in for physics. Now, a couple to notice here are speed. Speed's unit is meters per second. And it's got a funny way of showing that. It's got ms minus a little -1 at the top. Acceleration is meters per second per second. It's got a wee m with an s -2 at the top. So those are the units that are associated with those quantities. Okay, so now that we've been introduced with these, we can start to look at actual equations and how to solve real world problems to get the answers we need. My next video, we're going to look at velocity and motion. Okay, thank you.